Hello, this is Mr. Wynn, and this video is about the Pythagorean Theorem. So the Pythagorean Theorem states that if you have a right triangle with legs A and B and a hypotenuse C, the following equation is always true. A squared plus B squared will equal C squared. C must be the hypotenuse, which is always across from the 90-degree angle. It's also the largest side of a triangle. And then A and B can interchange. Sometimes I like putting A on bottom and B on the side. Sometimes I put B on bottom and on the side. It does not matter. C is the one that's locked across the 90-degree angle. So with the Pythagorean theorem, if you know two sides in a right triangle, you can always calculate the third side. Just be sure to label A, B, and C correctly. So here's two little problems. On the top left, we have a triangle. C is across from 90, so this is X. Then I'll call this A and I'll call this B. So if we do the Pythagorean theorem, it's allowed because we have a right triangle. It's going to be A squared plus B squared equals C squared. Now, I'll write the formula this time, but usually I don't. If I fill it in, A is 6, this is going to be 6 squared. Plus 8 squared equals X squared. 6 squared is 36. 8 squared is 64. That equals X squared. Add 36 with 64 is 100 equals X squared. Then you're going to square root both sides. So we just did a video over radicals, but 100 is a perfect square. That's just 10. So 10 equals X. So we just found that the hypotenuse is going to be 10 here. Over here, similar problem. We have a right triangle and two numbers. We can do Pythagorean theorem. Make sure you know which one's C. C is across from the 90, so here's C. Here's A, here's B. All right, I'm not going to write the formula this time, but I will fill it out. A squared, so 12 squared, plus B squared, so that's X squared, equals C squared. 144 is 12 squared, plus X squared, equals 169. I subtract 144 to both sides. I get 25. I square root both sides. Square root 25 is just 5. So we found what that is. Side note, the missing side could be an irrational. There could be a radical answer. Alright, it's not always a whole number. Alright, the Pythagorean theorem is great for finding things like distance between 2 points and also the height or shadow length as long as you know two sides of the right triangle. So here it says find the distance between the point 1, 3 and 9, 7. So I already plotted both points on the graph. So we could do the distance formula, but it's easier to do the Pythagorean theorem. I just need to draw the right triangle. So I just, from one point, I'm going to go directly sideways. And then the other one, I just go directly vertical, up and down. Remember, we have a up and down line and a sideways line. That's always going to be a 90-degree angle, right triangle. So now I got to fill in the sides. How long is the bottom? So I just count. That's 1, 2, 3, 4, 5, 6, 7, 8. This is 8 units long. How tall is this triangle? 1, 2, 3, 4. 4 long. And then this is what's missing. I'll call this X. Alright, so now you see the right triangle. We're going to do the Pythagorean theorem. Make sure that we're A, B, and C. So C is across the hypotenuse. I'll call this A and I'll call this B. Again, A and B don't matter. If you want A to be 8 and B to be 4, that's fine. Fill in the formula. A squared plus B squared equals C squared. 4 squared is 16. 8 squared is 64 equals X squared. Combine, that's 80 equals X squared. And then square root both sides. Now, unfortunately, 80 is not a perfect square, so I have to do some work. Again, I can't use a calculator. I need to break down 80 on the side. I'll do it right here. So square root of 80, we learned the tree branch method. 80 does turn into, I'll use this. Let's do 4 and 20. 4 is 2 and 2. 20 is 2 and 10. And then 10 is 2 and 5. Alright, so here's a pair of 2's. Here's a pair of 2's. That 5 is unpaired. So outside will be a 2 and another 2 and inside will be a 5. That really turns into 4 square root 5. So square root of 80 turned into 4 square root 5. That equals X. That's the distance. Alright, irrational answer. And that's perfectly fine. Alright, you can always do the Pythagorean theorem when you have a right triangle with two known sides. But there are times where you don't have to do work. If the missing side is obvious, no work is needed. The obvious cases are called Pythagorean triples. And these are really good to learn. Here are the 5 most common. 3, 4, 5. So if you have two legs, one's 3, one's 4, the hypotenuse has to be 5. Or maybe you know the hypotenuse is 5 and one of the legs is 3, that means the other leg is 4. I mean, you already know the numbers using Pythagorean Theorem, but it's just a quick pattern. If you see it, you use it, no work. 5, 12, 13 is another Pythagorean Theorem triple. 7, 24, 25, 8, 15, 17, 9, 40, 41. All right, also, side note, any multiple of a Pythagorean triple is also a triple. So if I do 3, 4, 5 times 4, multiply by 4, 3 times 4 is 12, 4 times 4 is 16, 5 times 4 is 20. So 12, 16, 20 is another triple. And actually, let me show you this. What if I do 3, 4, 5 times 2? That will give me a 6, 8, 10. That's also another triple. Let's go back to the very first problem. Notice this triangle right here, that's a 6, 8, 10, right triangle. So if I knew that or used it right away, I didn't have to do the work. I would have known that X or C was 10. All right, so that's just a good thing to know. The Pythagorean theorem can also be used to tell us if 3 sides form a right triangle or not. You know, if the Pythagorean is true, it's a right triangle. If it's not true, then obviously it's not a right triangle. So the question is the side lengths or does side lengths 5, 6, and 10 form a right triangle? Well, let's check. C has to be the biggest number, and we'll call this A and this B. So we're trying to see, does A squared plus B squared equal C squared? If it is equal, then yes, it's a right triangle. If it doesn't equal, then nope, it's not. So it's filled out. 5 squared plus 6 squared is supposed to equal, I'll put a question mark here, 10 squared. Well, that is 25 plus 36. And that's supposed to, that equals 100. Combined terms, what is that, 50, 61 equals 100. Those are not the same thing, so nope. So this is not a right triangle. Again, the Pythagorean theorem only works for right triangles, so if it's true, it's a right triangle. If it's not true, it's not a right triangle. All right, but one more thing is this. Last slide. If 3 sides don't form a right triangle, the Pythagorean theorem can actually tell us some information about whether the triangle is acute or obtuse. So this is where we use what we call the Pythagorean inequalities theorem. And it looks just like the Pythagorean theorem, but has an inequality sign. So the first one says if A squared plus B squared is greater than C squared. Now really I think meaning C squared smaller, then the triangle is acute. If A squared plus B squared is less than C squared, meaning C squared is bigger, then the triangle is obtuse. So it all depends about C squared. If it's equal, it's right. If C squared is bigger, that means it's obtuse. If C squared is smaller, then it is acute. So the question here is, what kind of triangle has the sides 3, 6, and 8? Classify it. So again, C must be the biggest number, so let's call that 8. Let's call this A, let's call this B. Let's compare what A squared plus B squared and C squared is. Let's do like that. And I'll put the sign. I don't know the question mark sign. Maybe it's less than, maybe it's greater than, maybe it's equal, who knows? I'll just not put that. A squared is 3 squared, B squared is 6 squared, and C squared, maybe I should do like this. I'll draw a straight line. All right, C squared is 8 squared. All right, so this is 9 plus 36. This is 64. So this is 45, and this is 64. So what is the sign here? 45 is less than 64. 45 is equal to 64. 45 is greater than 64. Well, obviously 45 is less than 64. Now look about C. C squared is bigger than A squared plus B squared because 64 is bigger than 45. If C squared is bigger, this is an obtuse triangle. All right, and you will see that on Get More Math. All right, that is it for the video. Thanks for watching. Make sure you ask some questions. See you soon. Bye.